science presentation in astronomy, we've gone from astronomy to the edge of the universe where we encountered infinity, and that caused us to switch tacks to cosmology to see what science has to say about the edge of the universe. And from there we discovered the redshift is critical to the current cosmology, and in order to understand redshift, we need to understand the geometry of light. And so that turns us to quantum mechanics. That's the quantum paradox, is that a wave is not really localizable, and that is the quantum paradox. So Roger will be talking about that today in our very brief clip from Lex Fridman's classic interview with Sir Roger Penrose. Let's hear what Lex Fridman pumps out of Sir Roger Penrose, one of the greatest scientists who's ever lived. Here we go.
But I found this very exciting because I thought these structures, these little tubes, which inhabit pretty well all cells, it's not just neurons, they're very, very symmetrical structures. And I had reason to believe that these very symmetrical structures would be much better at preserving a quantum state. That's where I think the non-computability comes in.
So something about the measurement process and what's going on, something about the structure of the microtubules.
Yes.
Your intuition says maybe there's something here.
Yes, it just struck me that partly it was the symmetry. You can preserve quantum coherence much better with symmetrical structures. And so there's a good reason for that. And that impressed me a lot.
So that's counter to the notion that consciousness might arise from the computation performed by the synapses.
It's not just that. See, it's more outrageous than that. You see, this is one reason I think we're so far off from it, because we don't even know the physics right. You see, it's not just quantum mechanics, but you have quantum effects, which are not just chemical, in photosynthesis. That photosynthesis seems to be a basically quantum process, which is not simply chemical. It's using quantum mechanics in a very basic way. So you could start saying, oh, well, if photosynthesis is based on quantum mechanics, why not behavior of neurons and things like that? Maybe there's something which is a bit like photosynthesis in that respect. But what I'm saying is even more outrageous than that. My argument says that conventional quantum mechanics, if you're just following the Schrödinger equation, that's still computable. So you've got to go beyond that. Quantum mechanics goes wrong in a certain sense. You have to be a little bit careful about that, because the way people do quantum mechanics is a sort of mixture of two different processes. One of them is the Schrödinger equation, completely deterministic, but it involves into ridiculous situations. And this was what Schrödinger was very much pointing out with his cat. That would be the evolution of the Schrödinger equation would lead to a state, which is the cat being dead and alive at the same time. And he's more or less saying, this is an absurdity, there's something missing. And that the reduction of the state, or the collapse of the wave function, or whatever it is something which has to be understood. It's not following the Schrödinger equation. It's not the way we conventionally do quantum mechanics. There's something more than that. At least three of the greatest physicists of 20th century who were very fundamental in developing quantum mechanics, Einstein one of them, Schrödinger another, Dirac another. You have to look carefully at Dirac's writing, because he didn't tend to say this out loud very much, because he was very cautious about what he said. You find the right place, and you see, he says quantum mechanics is a provisional theory. We need something which explains the collapse of the wave function. We need to go beyond the theory we have now, that quantum mechanics needs to be modified. There's a small minority of those people, which are already a minority, who think that the way in which it's modified has to be with gravity. And there is an even smaller minority of those people who think it's a particular way that I think it is, you see. So
those are the quantum gravity folks. But what's...
You see, quantum gravity is already not this. Because when you say quantum gravity, what you really mean is quantum mechanics applied to gravitational theory. So you say, let's take this wonderful formalism of quantum mechanics and make gravity fit into it. So that is what quantum gravity is meant to be. Now I'm saying you've got to be more even-handed, that gravity affects the structure of quantum mechanics too. It's not just you quantize gravity, you've got to gravitize quantum mechanics. And it's a two-way thing.
And we have to figure out a totally new ideas in
Exactly.
All right, a totally new idea. I hope you enjoyed that. You'll notice at the end that gravity was brought in. Of course, this is now referring to the unified field theory, which is the highest goal of science right now. A couple of interesting points are brought out here. These are not new points, but they're points that need to be borne in mind. There is no theory of quantum mechanics. And Sir Roger brought that out quite carefully. The Schrödinger equation is a deterministic equation which does make accurate predictions about quantum mechanical phenomena. But there is the state, and the state is really what we're after in physics. It's fine to make predictions, but we are making predictions about state. And when he refers to Schrödinger's cat being dead and alive at the same time, he's referring to the fact that that's an absurdity. And it's just the way it is in this paradox that using the deterministic equation leads directly to the paradox in this particular context, but all of this fits together into the same paradox system. I call this the quantum mechanical paradox complex. Now we're talking about structure. And the common aspect of the structure of this complex is something imaginary. It's obvious that this imaginarity is brought forth in the dual state of the cat. Schrödinger was lampooning the theory because there is no theory. So essentially, he's pointing out that we still need a theory. And that is what Einstein said. And Sir Roger also carefully pointed out that this was also Paul Dirac's view, that this is a provisional theory. That is, the equation of Schrödinger is provisional because it produces a state where the cat is both alive and dead. It's the superposition of the dead and alive state. And the reason Schrödinger chose to kill a cat, which I'll bet that he likes cats, he was trying to point out how serious this is. That his equation that he invented, he didn't even like it. That matches Max Planck's discovery of the quantum. He actually tried to deny his own discovery because he didn't like it. And it's worthwhile reading what Max Planck says about his discovery. He said it was an act of desperation. But it began the quantum revolution. Paul Dirac introduced a relativistic solution, which is somewhat different. But the Dirac equation is different from the Schrödinger equation. What we're concentrating on here is the superpositional state, because the way Sir Roger brings this out, we need to have an explanation for the split state. This is what Einstein called spukhafte Fernwirkungen. Newton dealt with the same basic situation in his formulation of gravity, is spooky action at a distance, and he wasn't quite sure what that meant. He says it's not his job to interpret. His job is to measure. Well, now in quantum mechanics, we have something called the measurement problem, which introduces all kinds of spooky aspects to what are the experimenters doing when they force the collapse of the wave function. This has led to the extraordinarily famous and popular many-worlds theorem. The many-worlds theorem itself is a mystical view, because it says that reality splits. so that if the cat is alive at the end of the experiment, that means another universe split off with a dead cat. Well, of course, that is simply mysticizing what happened. In the superpositional situation that is forced by Schrodinger's wave equation, there has to be a split state. Well, immeasurable or measurable, no one's sure, but it's some where the cat is both alive and dead. And it's just paradoxical, nobody can get around it, that for a while they're both true. Well, what does that mean? That's really the quantum paradox. Well, I have the solution. It had to be geometric. Of course it's geometric. You can approach this in several ways, and entanglement is closely related to superposition, that you have two particles in an entangled state. And when you measure one particle, it instantaneously changes the state of the other particle, which violates light speed. There's no actual transfer of information, so all of these Alice and Bob experiments, you can forget them. My goal is to get the answer to the quantum paradox. We need to know about the flight of the photon. We need to know about how light propagates through space, so we can reinterpret the redshift of cosmic light, because the universe, children, is not expanding. But you might think so if you interpret redshift as Doppler shift. It's not Doppler shift because it's not sound. Doppler shift only applies in a medium such as an atmosphere. Light does not do that, but it does have a redshift and a blue shift. Just as sound waves have a compression which raises the frequency, and then when the train passes, it decreases in frequency. That is the sound equivalent of blue shift and red shift. But light does not do that. It does something much spookier. And here's another point I wanted to bring out, which Sir Roger comes through. I'm totally with Roger on his point of view, that quantum mechanics is not spooky enough. He's trying to address the question of consciousness on behalf of Lex Fridman's interest in AI, which Lex Fridman is an AI presenter. So he wants Roger to comment on artificial consciousness. Well, artificial consciousness has been popular for centuries. Why is it so attractive to the science fiction mind? Oh, it's because of consciousness, the mystery of consciousness. And here's the kicker, so you'll tune in. The nature of entanglement is two separated particles, where when you change the state of one by measuring it, it instantaneously changes the other. That is an exact equivalent of the collapse of the wave function, because as we discovered from Christian Huygens, that the propagation of a photon is as a spherical wavefront. Well, that means it has a radius as it expands. But the whole sphere is a proton, and that sphere expands. And when it gets to your photographic plate or your eye, the whole sphere collapses at once, in no time at all. And Einstein just lost his shit over this. He couldn't stand it. And so what he said was, is your quantum theory, and it was partially his theory, let's not forget that, it's Einstein who proved the particle nature of light. He got the Nobel Prize for it, and we all accept, is a particle. But is it? Well, one thing we can definitely say about it, it's a geometric object, because a sphere is a geometric object. That is the secret. We're not measuring the spherical component of light on its own terms. We're always using linear numbers. Space-time is a linear system. Well, it adds a spheric function. For the same reason that complex numbers, a 2D system with one imaginary axis, you see the relationship. Space-time is a 3 linear axis spatial system with a 4th imaginary axis. The only problem with that is the 3-1 split. But the way it works is with four-tensor calculus with a gamma term in pseudo-hyperbolic space with a light cone. That simply is incorrect. The light does not travel as a cone no matter how you look at it. It travels as a sphere. Now, that's not quite fair to Einstein because he wasn't specifically addressing light propagation. He was addressing the opposite. Light propagation can be conceived as a centrifugal force, as I've proved, and you can check the previous 3 or 4 lectures for that, or the previous 350. But gravity is a centripetal force. It's the integral protonic force. It's bending space. But as space bends, something has to be said about time. Now, what Einstein said is that space is 3 and time is 1. What I've discovered is that space-time is 2, which is obviously correct. But we don't have a mathematics for it. That is, we don't have an algebra for space-time. So space-time algebra that's being used is 3-1. It's an extension of complex imaginarity. The imaginarity comes from the square root of -1. You really have to see that to appreciate why it creates a circular function in the plane. Think of the square of 1. The square of 1 squared is 1. That's magical. Because it's the same 1 in square space. It's a different metric, so that you have a square that's 1, but it's made from 2 sides that are 1. So the 1 times the 1 equals 1 in another form. That's magic. That leads to the Pythagorean theorem, which is why we're able to get at circular and spheric space with the Pythagorean theorem. It's because of the peculiar nature of the number 1. Well, then there are the negative numbers, which are not used in distance measurement. Everything in the universe is positive. There are no negative distances. And I've already taught you that the line is only useful for linear spatial separation. Now, you can use the other direction. And you do need both directions because that line has 2 directions, right? And one of them is negative. If you're using linear spatial separation, then the index goes forward 1, 2, 3. But as it does so, there's a negative effect of -1, -2, -3, which is balanced on 0. It's balanced on linear 0. That's the definition of add on the line, and that's been proved, so you can accept that. That's so simple that it may sound mysterious, but it's so simple that it leads to an extraordinary insight, because what is multiply? That's a 2D operator, because 2 times 3 makes a rectangle, but 3 times 2 makes a different rectangle. They both make 6, but they're oriented at a 90-degree angle. We're taught that multiplication is commutative. No, it's not. It's not commutative. And so here's the point, pardon the pun, if you go negative and use -1, if you take its square root, that's the inverse of the square. Well, what happens since it's negative and you're taking the inverse of the square, it does something else magical, but it's not linear. It is linear until you learn about the magic number e, which is its own derivative. It's a very magical number. I believe it's 2.71828. It's a magic number because it's its own derivative. And if you use e with the square root of -1, it makes a perfect circle on the plane. And that's why e to the I pi power equals -1. Because when you start at +1, you're actually taking a power of e. Take e to the imaginary pi power, e to the I pi power goes to -1 on a circle. You can do that without using negative numbers. You need proportional numbers which produce spheric space. So I hope you stay tuned. This is ANAGALACTIC bringing you the secret of the universe so we can understand entanglement and superposition, so we can crack the quantum mechanical paradox for the first time in human history. I have done so in order that we can understand redshift of cosmic light, and from that we can get back to the origins that we need. You also need to know your human origins. We have no idea where the ecology came from, and I think you know where that leads. You're going to have to believe somebody about that. You don't have to believe anybody if you're a scientist. You're allowed to say that you don't know. But if you say that you're descended from amoebas and monkeys, that's been disproved. Stay tuned to ANAGALACTIC for the secret of the universe, the solution to the quantum mechanical paradox, only from ANAGALACTIC.